So, yes, sorry. Assalamualaikum and hi. My name is Muhammad Azhar, and my group is Abdullah and also Anindita. Okay, so we'll start explaining on our code. Okay, so for the first line is import CV2 as CV. So we can use the OpenCV library as the alias CV. And also for the second one is numpy. So NP as the alias. So we can use NP for the numpy library. And for the third, fourth, and fifth line, we use tkinter file dialog. So we can ask the user for a file. The fourth line is for simple dialog. So we can ask the user to input anything. And use tkinter STK. So yeah, it's for easier use as alias. And okay, for the ninth line, this is for us to prompt the user to use which method. Is it global or adaptive thresholding? So as you can see on the screen, we can the user can input either 1 or 2. So let's say we input 1. So we can use global thresholding. Okay, so yeah, to explain the code. All right. Yeah, we can use 1 or 2. All right. So for the 12th line, so root equals to tkinter.tk. That one is for us to open the dialog. And for the second, for the 13th line is for us to hide the window, and proceeding to 14th line, asking the user to open the file. Okay, so for the 16th line, the code will read the image and set it as image. And for the 18th line, the color will be converted to from BZR to gray. At the 21st line, we'll go to cb.bilateral filter. So the image is smooth. So for the next one, the else and if, I'll pass to Abdullah.
Okay, hello. So we will be now explaining the methods that we'll be using in this program or in this code. So as Khairul mentioned, so we are using adaptive thresholding and global thresholding. So when you first run the code here, you'll be presented with two options, so either global or adaptive. So if you choose number 1, which is global, then you will have to, after choosing an image here, then you will be asked to enter an integer, and that integer will be the our threshold value. So if you try clicking one here and then choosing one of the images, you'll have to enter a threshold value. So from 0 to 55. And then next up, the thresholded image, the thresholding value that we chose will be put in the thresholding function, where the image will be thresholded using a binary thresholding type of thresholding. That way it will convert it to binary, and then check it for each pixel, and then make sure or check if it's above or below the thresholding value to convert the pixels to either 0, which is black, or 1, which is white. Next up, we have the second choice, which is choice 2, where if you choose this choice or enter the number 2, the program will choose the adaptive thresholding method. Now, in this method, we are using the adaptive thresholding mean, where it takes the neighborhood of that pixel, and then it gets the mean, and then takes that value as a new value for the pixel. We're also using the thresholding, the binary thresholding here. Some parameters where we have, this is the 21. The value 21 here is the number or the neighborhood or number of pixels in the neighborhood. This value has to be odd. And then number 5 here is the value that has to be subtracted from after calculating the mean of that neighborhood. Then that image is then saved after applying the thresholding, adaptive thresholding method. It will be then saved to this variable right here. As you can see, we have 2 variables, both the ifs. So you have to choose one, and then that will pass through this line right here, and that will be explained by my member Anindita.
Okay, thanks, Abdullah. So for median blur, we are using it mainly to reduce any kind of noise we have, and also the salt-paper noise and blurring the image a little bit to make it more smoother. And here we have our parameter and using the threshold image that we got in the previous section, and also our kernel is 3. And other than that, this same median value we are taking for the mask as well, where we are using the highest pixel value 255, and we are subtracting the median value from it to mask the image. And for our final result, we are using the library function, which is bitwise end. And for this, we have to take parameters of two numbers, where we are taking the image and also the masked value, so we can create and overlay the end result. And after doing the result part, we are going to IAmShow, which is another library function to show the image we have created. And then here we have quite a few like outputs here showing the main image, the threshold image, the output result, and also the median, applied the median blur result. And after that, we have to save the image, like the main result, into our drive using IAmWrite, and then we just destroy the window after we have done using it. And that's it for this one. So maybe Abdullah, you can do like one round of showing the full output.
All right, then let's start by running the program. Right, as mentioned, we mentioned before, we have to choose from the two methods here. So let's choose method number 1, which is global thresholding. And then let's choose this image of the signature right here. Then we will be have to apply or give the program a thresholding value. Let's go with the value 120. And then we will be presented with these windows over here, as you can see here. So this is the original image on the left. Then this is the thresholding after applying, or this is the image in binary after applying the thresholding method. Then this is the median to clean any noise in the image. And then this is the output. As you can see, it only marks the area that we're interested in, which is the signature. So as my member Anita mentioned, we are using the bit and function here, where we're multiplying the mask, this one right here, along with the original image to only get this area in the image, which is the signature. We can also try applying this to other images. Let's choose this stamp right here, for instance. Let's give it the same threshold value. As you can see, this is the original image, and this is the thresholding, and this is median, and then this is our output. Now we can also increase the value in order to get better results. Maybe if we try 130 here, we can get a better result. Let's also try doing the images with the shadows, right? So these two images here. So if we try the same value, 120, we notice that we're not actually getting very good results. So this is the original image, and this is the thresholding value. This is the median, and this is our output. So as you can see, it doesn't really perform well, which is why we can also use the adaptive thresholding, and that should give us better results. So when we choose adaptive thresholding, we're not giving the program any value or any thresholding value, since it calculates the mean of the neighborhood of each pixel. So let's try doing this one, for instance. So this is the original image right here. And then you have thresholding value. As you can see, it's very, very different from the one that we saw before when we used the global thresholding. This is the median in order to clean up some of the noise in the image. And then this is the output. Again, you can also play around with the, sorry, no, this is adaptive thresholding, so we can't really change the thresholding value, but we can change the number of pixels in a neighborhood, as well as the number that's subtracted from the mean here. This could also give us better results. And then lastly, let's just try one more time using adaptive. And then let's try one of these signatures, for instance, this one, the text and signature. So this is the output. As you can see, it only marks that area where we have text and the signature. But we still have a little bit of noise all around the image. That can also be improved once we change the parameters in this function right here, which is the adaptive thresholding method. I believe that's it. That's the end of our explanation for this program for assignment 3. Thank you very much.